In VEX Robotics, there are two types of competition matches, skills and tournaments. In skills matches, you're competing against the clock in a solo round. You get 1 minute for driver control, where the robot is acting on driver input, and 1 minute for an autonomous period, where the robot is acting completely on code. In tournament style, you are competing alongside another team and their robot against another alliance of two. You get 1 minute and 45 seconds of driver control and 15 seconds of an autonomous period. Today, we are going to make an example tournament autonomous for the Clawbot. Before we start, there are two components that help in coding an autonomous period: wait commands and sensors. First off, wait commands will really help with the timing of your auton. In C++, you do this with the syntax wait, then your time, then your units. Mine's going to be seconds. So this would be an example of the robot completely waiting for 5 seconds. These are best usually to use an auton, since waiting will stop your code from getting any input, and you don't really want your robot freezing on the drive field. Next, sensors are a big component you can use a lot. It's especially helpful when you don't have human input, i.e. during an autonomous period. A vision sensor gives sight to your robot. It can detect up to 7 colors at once, including on multicolored objects. And it can also collect information about the environment, recognize patterns, and can even be used to follow an object. Next, an optical sensor is a similar but slightly less complex alternative to the vision sensor, featuring an ambient light sensor, a color sensor, and a proximity sensor. The distance sensor uses a pulse of laser light to measure distances from the sensor to another object. It can also calculate the robot's approach speed towards an object and the relative size of the object. The inertial sensor can detect a change of motion or direction of the robot in all 3 axes, using an accelerometer and a gyroscope. It electronically maintains a reference point so that it can measure the rotational change in your robot against that reference. And finally, the rotational sensor measures rotation of a motor shaft. Once a motor shaft is inserted into one end, it can measure rotational position, total rotations, and rotation speed. But for our purposes, we're just going to use a distance sensor. But if you want to find code for the other sensors, check out the VEX documentation. So, before you code your auton, it's important to plan out where you want to go. In this autonomous period, I want the Clawbot to move forward until we're about 2 meters from the wall. Then turn left, wait a couple seconds, and move forward again. Making sure to be in the autonomous section of your competition template, let's start. So, we're going to do a while loop first. And a while loop is just like an if loop. It takes a condition, and while that condition is true, it performs a set of action in these curly brackets. So, our condition is going to be the distance sensor reporting distances less than 200 millimeters. So how you're going to do this is first we're going to access our distance sensor, which I've defined as distance. And then we're going to call the variable object distance in millimeters. Then we need to say is greater than 200. And so when the distance is greater than 200, we know that it hasn't reached 200 millimeters from the wall yet. We're going to call our action. And in this case, it's going to be moving the left motor forward by spinning and moving the right motor forward by spinning. So, usually in an autonomous period, you're going to use spin for commands so that you can more accurately have the distances of your robot and you can tweak them. But we're going to be using spin here because it's inside of a while loop. And so, while that function is met, they're going to spin. But as soon as the function is not met, when we get distances less than 200, we're going to stop the motors. There we go. So now we've accomplished the first part of autonomous. We have moved forward until 200 millimeters. and then we are going to turn left. So how this would be is using the right motor, and then spin 4. I'm going to spin it forward since we are turning left for 2 turns. And be mindful that this may not be the right way to turn left to the accurate distance in your robot. It depends on your robot's size, the material on the ground, etc. This is just a baseline. So after we have spun for 2 turns, turning to the left, we are going to wait using our handy wait command. And so remember, we do wait, then our units, we're going to do 5, and then our units, seconds. Another option for units is milliseconds, but this will be easier. And then finally, we are going to move the robot forward again. We're going to use spin 4 since we are not in a while command. But we're going to add something very special on since we're using both motors at the same time. So let's turn forward for 3 turns. But instead of ending the function here, we're going to add another parameter, which is false. So what this false does is there's actually a hidden optional 4th parameter on left motor, which is the parameter isWait. So what isWait does is says the function, should I wait until the entire function is completed before moving on? And in this case, since we want to move to the right motor immediately as soon as we get that command for the left motor to start, not after it's finished, we're going to add false on the end there. We're going to do the same thing on the right, and we're not going to add false on the other parameter since we want to wait the entire length of the motor spinning. But whenever you use spin 4 to move forward or even to move 2 motors at the same time, always make sure to add that extra parameter there. And I think we have finished our autonomous coding. So now it's time to go test it.